Nowadays, we are using more and more finite products as raw materials for production and energy supply. These products can also be found in, of all places, our rubbish. The Kahlenberg Waste Treatment Association, ZAC for short, has managed to use waste as a resource and to extract the maximum amount of energy potential and raw material from household waste. Through the use of the innovative maximum yield technology, the association's mechanical biological waste treatment facility works reliably, is self-sufficient in terms of energy use, and has almost no emissions. The end result is that high-quality raw materials and energy sources are generated in the form of economically useful products from over 100,000 tons of waste each year, thereby making an important contribution to the conservation of resources and the prevention of climate change. MYT consists of 5 tried and tested, perfectly synchronized process steps. The first step is the intake of waste. The delivery hall. This is where the waste begins its journey through the MYT facility, and also the last point at which it can be plainly seen. A digger loads 2 conveyor belts equally with the waste that has been delivered, and sorts out large impurities and recyclable waste. The checked waste then proceeds in metered quantities to step 2. Mechanical processing. Here, the waste is automatically separated according to material type and differences in size. The concepts and systems used are based on ZAC's many years of experience and guarantee safe operation and the systematic separation of fuels, minerals, metals, and the small amount of non-recyclable residual waste. The checked and processed waste then proceeds to the third step of the process, the biological stage. In the new and intensively tested defined aerobic mixing process, DAMP for short, the waste is selectively reduced in size and homogenized using a horizontal agitator. Processed water is added as part of a cycle, thus ensuring an appropriate, unchanging consistency. After being in the mixer for a short period of time, presses are used to separate water from solids. A portion of the microbially assimilable organic material is washed out with the resulting press water, then purified several times and used to generate energy. The water treatment. MYT incorporates a new practice-proven and mature water treatment. The processed water from the biological stage is mechanically and physically processed to separate coarse and fibrous materials. Microorganisms living in biogas fermenters create biogas from organic compounds. This biogas is then used in the nearby cogeneration unit to generate electricity and district heating. In the process, more electricity and heat is produced every year than the entire mechanical biological waste treatment facility itself needs. At the end of the water treatment process, purified water, water for agricultural irrigation purposes, or nutrient-rich liquid fertilizer are all available. Apart from water management, the ZAC is also setting new standards when it comes to exhaust air treatment. In order not to spoil the natural environment with exhaust air, which is usually quite pungent, a differentiated and innovative exhaust air treatment system is in operation. All the process steps, systems, and conveying methods are enclosed, with the polluted air suctioned off on an ongoing basis and fed into the exhaust air treatment facility. Exhaust air, which is less polluted, that from the halls for instance, is purified in biofilters. Biofilters are containers filled with natural materials like bark mulch, in which microorganisms ensure that the odorous substances are mostly broken down into carbon dioxide and water vapor. Air washers and a regenerative thermal oxidation system take care of the purification of process air streams that are more heavily polluted. Step 4. Biological drying. After the separation of water from solids is completed, some microbially assimilable organic material remains in the solid material, thereby allowing a biological drying to take place that is both energy-saving and economical. In tightly sealed concrete tunnels, air passes steadily through the waste, providing the microorganisms with oxygen. These microorganisms feed on the material's organic components and produce heat energy for drying. After a brief treatment period, a homogeneous, dry and fine solid material is available, which can subsequently be easily broken down into its constituent components. Step 5. Mechanical material separation. The mechanical material separation works completely automatically using a specially configured technology. Screening and sifting systems then break down the material from the biological drying process into different fractions. Energy-rich combustible materials as well as minerals are transported through special conveying systems to the loading stations and can be dispatched without requiring any further treatment. The goal has at this step been achieved. Economically utilizable raw materials and high-quality energy sources have been obtained from waste material. In industrial processes, this can be used to replace fossil fuels like coal and crude oil, for example. This conserves resources and reduces carbon dioxide emissions, which is good news for the environment. The products created by the MYT process illustrate clearly the great potential that exists to create energy and raw materials from household waste with minimum impact on the environment. This means that only small amounts of waste will have to be burned in incinerators. See for yourself by visiting the ZAC in Ringsheim. MYT can be seen up close by the people and is waiting to be explored and marveled at. The facility is situated amidst nature, where not only goats and donkeys can be found in the vivarium, but also where rare and endangered plant and animal species can be seen. Located among profitable vines in harmony with nature and accessible to the public, since 2006, something has been achieved here that lots of people would still consider to be a pipe dream: the generation of energy and raw material potential from household waste.